I don't even know if it's picking up the sound or not. Can you hear me? I think the sound's coming through. Yeah, right, okay. First telescope. This is the easiest telescope, the simplest one. There's the tripod. It's a very lightweight, flimsy tripod. This is a Celestron 114 AZSR, I think it is. So it has an altitude azimuth mount. So this is the scope. This is the scope itself. It's not hugely long. It's got quite a nice laser finder on it. I did a review on this a while ago, so I don't need to dwell on this anymore. But it's a Newtonian reflector. So I take the lens cap off it. And you might be able to see inside. You might not be able to see the reflection inside. I don't know. There's a delay on this, so I'm not sure. Oh, lovely, the sound is coming through. Right, so I'm getting the messages coming through on my phone. So you can see the mirror at the bottom. So you've got the primary mirror at the bottom there. Secondary mirror is in there. You're going to view through the eyepiece here. And all you do, it couldn't be easier. All you do is you loosen the screws at the sides here, like that. Riveting stuff. Put it in this stand here, like this. There's a bar at the side which you can put through, like that. Tighten them back up again, not too tight, they need to be loose enough that you can move them. I'm only really recording this video, so I've got some footage I can fast forward later. Just like that. Ta-da! Done. I mean, we could make the legs longer because it's a long way for me to bend down, but it's very flimsy mount. This was a very cheap telescope, around about £100, something like that. My wife got it for me one Christmas as a nice surprise, and it was a nice surprise. Biggest complaint online about this is the mount, and that's for good reason. The mount is terrible, but the optics seem fine. I've managed to get pictures of Venus, Saturn, Jupiter, Mars. Not very good pictures of Mars yet, I'm still working on that. The Orion Nebula. There's plenty of pictures of the moon, so it's not terrible. But there we go. Took the lens cap off the end. What we've got to do is pop a eyepiece in here, and then get the whole thing focused and collimated, and that's it. So the way this works, you want to look at something, all you do is you loosen everything, you grab it whilst looking through this viewfinder there, you point at what you want to look at, you then tighten everything, and then you look at it. That's it. That is how to use an alt-az mount, an altitude azimuth mount. So called because you can directly change the altitude. You do that just by lifting this up and down. That's the altitude. And the azimuth, that's that one. Now the problem with this sort of mount is that, there's a screw here to tighten up the azimuth. The problem with this sort of mount is that if you're looking at, let's say, a star or a planet, it's going to be following an arc across the sky, or appear to do that, because of the Earth rotating. So as the Earth is rotating, all the stars appear to be moving around Polaris, the pole star. And the planets do as well. Yeah, the planets change their position relative to the stars, but across the course of a day, or throughout the course of the night, while you're observing, you're not going to see them move that much relative to the background stars, but you'll still see the background stars move quite a lot. About a degree every 4 minutes, I think, if I remember rightly. So having to find a planet that's moved out of your view by making two adjustments, an altitude adjustment, which is this one, and an azimuth adjustment, that's that one, is a bit of a nuisance, especially given that what you're looking at is going to be upside down, because that's how telescope optics work. So that's going to be more than a little bit of a nuisance. So we have a different sort of mount. And I've just noticed that this is broken again. Look at that. Look at that. I glued that, and it appears as though it's broken again. So I might have to get this one 3D printed and repaired. 3D print another strut that goes across there, because that's broken. Nuisance. So let's get a different one. Let's get the equatorial mount. In my opinion, is it good for planetary observation? Not really. It's fine for a beginner, and it's probably easier to set up for a beginner. And if you want to see just see planets with your own eyes, then again, for a beginner it's not bad. But for any sort of photography you want to take, especially if you want to take photographs over a long period of time and stack them together, you don't want the planets really moving around in your field of view, which means that an equatorial mount is far better. The optics are fine to look at planets though. Right, let's have a look at the other one. So this telescope was donated. One of the students I teach, I think it was their grandparent, died and donated this. And yeah, it's going to need a little bit of work to bring it up to speed, but you can see it's a little bit longer than the other scope, which has advantages. But the aperture's a little bit smaller, not a lot smaller, a little bit smaller. Actually, I've just measured the two together. It might actually be the same size aperture. The aperture being the size of the mirror in the bottom. Might actually be the same. So let's just pop that there and let's go get the mount. Because this one takes a bit more work to put together. Moving these stones out the way that I keep accidentally kicking. So here's the mount. See, straight away it's much bigger, much beefier than the other one. There are some plastic parts, but the plastic is thicker. Most of the parts are, I don't know, stainless steel, maybe aluminium for the legs, stainless steel for the struts that go across. It's much taller, which for a guy like me is going to make it much easier to use because I'm tall. So setting it up, first of all I'm going to extend all the legs so that I have to bend over all the time. It's cloudy at the moment. Then open up the tripod like that. Now you want to make sure this is really level. So if I had a table here, which really it should have on this middle bit where the struts connect, little table, I could put a spirit level, a two-dimensional spirit level there and see how balanced it is. So the mesh is saying that I look like nearly headless Nick and I should point it up a bit. No, because I need to see all this bit, so I don't want to point it up a bit. because the telescope's the important bit. Yeah, but I've got an app on my phone. Let me show you the app. I think it came with the phone, it might not have done. Do I consent to all my data being stolen? Yeah, sure. And it's just a bubble level. And so the idea is that I can lay it horizontally. I might have to calibrate it on a horizontal surface first. But then the idea is that I could lay it on the table, which this doesn't have, in this middle bit, and just check that it is all horizontal. I mean, that's actually not bad as it is. This bottom bit of the garden seems to be reasonably level. Perhaps that one could be pushed a little bit longer, or these two legs could be made a little bit shorter, but that's not bad. So that's the first stage, is making sure the tripod is level. What's the next stage? Well, you might as well get the telescope itself mounted on this. So I'm going to loosen all these screws so that I can move things. You can see that lifts up there. The telescope is going to go in here. All of these bits need loosening, and there's a tool to do that. Which I have right here. So it's a special tool, and there are places where I can connect the tool to loosen the screw. There's one here, and there's one right on the top there. Probably can't see it very well. So you just loosen all them so that all these parts can move freely, and all that part can move freely, like that. Now I'm actually going to bring this around like that, and like that. That's the angle I want it. Blue tack there. That's the angle I'm going to want it. So I don't know if you just saw what I did when I was transporting it or storing it. I had it like that, so it took up less space, and I lifted this up and rotated that all the way around, just like that. It needs to be loosened. There we are. So I've lifted that up and moved that so it's all the way around, and I'm going to put the telescope in this bit here. So what I'll do is I will tighten this bit up just for a second, not really tight, just so it grips, so this bit doesn't fall down that way. And I'll do the same thing. Oh, that's what I was looking for. I'll do the same thing for this. Not really tight, just so it doesn't slip down. Like that. I'll do the same thing for this. So now tightening them up with the rings at the top, those two rings. And it's those two rings that are going to hold the scope. Now I need to know where the centre of mass of the scope is, because that I want in between the two rings. If the scope's too far one way, it will fall that way. If it's too far the other way, it will fall that way. So I need to sort of have an estimate of where's the centre of mass. So it's around about there. Doesn't have to be perfect. Around about there. I wish I had a telescope. That's a cool app. Yeah, it does the job. The app works. It was a free one, which means that, you know, you are the product. If you're not the customer, which means you're not paying any money, then you are the product. So it's stealing my data somewhere. But I'm sure that's fine. I wish I had a telescope. Yeah, I mean, the Celestron over there, which is fine. I've done observations with that for years, and that cost very little. You could probably grab one second hand dirt cheap. And nearly finished unscrewing this. There we go. See, I'm seeing your messages that come through. So now I've just opened, by releasing the two screws here, I've opened these circular parts, just like that. Now I can just pop the telescope in, and remember I know roughly where the centre of mass is. I don't like just leaving it there because that could, you know, the whole thing could suddenly loosen because I didn't tighten it very much. But you can check it's about central. Now this raises an interesting question. Which way around should I have the eyepiece? Should I have it like that? Or should I have it over like this? At the moment I'm just going to do it so that the eyepiece is pointing that way. But we can change it later if we need to. And you probably will, over the course of the night's observing, change the rotation of the scope so you can get to the eyepiece, especially if you have it set up as tall as I have. The advantage of setting it up tall, I don't have to bend over. The disadvantage, it will actually wobble a bit more if it's taller. So I've been told, I haven't tested it yet. So really you want it as short as you can get away with to make it as stable as possible. Yeah, so you can get telescopes on things like the Facebook Marketplace. People buy them for a hobby thing, then don't use them. They occupy space in people's sheds or gardens or something like that, and then they want to get rid of them, so they just stick them dirt cheap on Facebook Marketplace or eBay. Again, that's what I've been told. I haven't found a cheap one yet. So that's nearly done, but not quite. Because if I loosen these now, holding it very carefully while I do it, if I loosen these now, look, it just falls straight down like that. So I need some sort of counterweight to balance it in the other direction. We've tried to balance it along this direction. We now need to try and balance it along that direction. So there's the counterweight. Yes. So here it is. It's a very big, heavy lump of steel and a bar. And the bar screws on here, and the lump of steel will just go on like that. So no tools are needed, and you should never tighten things too tightly. But that's a good philosophy for any sort of DIY. I can't tell you how many times I've broken stuff by tightening screws too tightly, like when mounting plug sockets and things like that. As long as it doesn't move, that's fine. So now we've got to figure out where to put this. You know, is that the right place for the counterweight? Or is that the right place for the counterweight? We need to figure it out. And that's going to be trial and error. So what we're going to do is we're going to loosen this again, holding it to make sure it doesn't flop. And we're going to see, so that's probably too far out. That's not far out enough. So let me tighten this one up again, and let's loosen that one, because that one's going to be permanently tightened anyway. And let's, where's that tool gone? There it is. Loosen this one. There we go. That's what we're trying to balance around there. Around that axis there. Let's just tighten this up. Right. So if that's too far in there, oh look, spins around that way. Actually, right at the end is pretty much the right place, looking at it. Maybe a little bit in from the end, but I reckon about there-ish is right. It's just to hold it in place. Right. Well, it's not set up yet, is it? What I can do is show you. If I loosen all these, you can see that if we are looking at an object, maybe it's over there, we have the telescope in this position, or we have the telescope in that position, and we'd be able to see the same object. If it's pointing at the same angle, pointing at an object, we could see it in two different positions. Now you've got to think that when you're looking, we're in the northern hemisphere, when you're looking and you're seeing stars moving around the sky, they're going to kind of come down this way. That's because that's where I'm looking. Imagine Polaris is there. They're going to come around that way. So you need to be able to follow them up, round, and then down. But with only moving this degree of freedom. So this one will be locked in place, and it will follow the stars around like that. That'll make more sense when I set it up fully. So let's do that. North is the next thing we need. We know where north is. And I reckon north is that way. I don't have, let me get tissue. I wonder if they manufactured it that way then. Yeah, they probably did. Probably designed so that it's the right position. Near enough. Look, it's moving all by itself. It just helps a little bit. Might not be perfect. So north is about that way. Now what I could do is get out a magnetic compass, and I might have one of them on my phone. In fact, I do. Most people with phones do have compasses on them. It's part of a suite of apps that I use called Smart Tools, which I paid for. So you can see we've got ourselves a compass there. You have to calibrate it first. Now, if it's a mobile phone one, that usually means doing some sweeping figure of eights with it a few times first, and then doing this. And this says the magnetic north is yonder. But the problem is, the magnetic north isn't the same place as the geographic north. And I need this pointing at the geographic north. So there's going to still be a rough alignment first, and then we're going to improve the alignment later. So on this mount, you can see that I can, this is all moved, make sure it's all level. You can see there's a screw here which I can loosen, and that allows me to turn the entire top table around. You see that? This entire top part is just moving around. And what I want to do is point that entire top part towards north. Now some scopes have a hole going all the way through these, so that you can actually look for Polaris and get this screwed in place when it's pointing at Polaris. You can have a special eyepiece you put on there. This doesn't have that. So I'll kick in the legs, because every time I kick it, it knocks the alignment off. So I'm just going to have to kind of wing this by eye. Not perfect. That way. And because this has got a camera, I can look through it and actually look to see that it's lined up with the north on my compass. But remember, that won't be the same as a geographic north. Let's say that's pretty much lined up. That's pretty much lined up. So now I want to tighten this screw to hold that in place. One of the bits of advice I saw is if you always use the telescope in the same place, mark off where you put the feet, then put a mark on the stand itself so that you can always, every time, just put it straight back in the same place and not have to do that step. I don't think that step takes long. I don't think it's a problem. Right, the next thing we've got to do, and you can't see it from where the camera is, but there's a dial here, a scale, and that scale shows 0 at the top, then 30, 60, 90 horizontally, 30, 60, 90 horizontally the other way. And there's a needle which is attached to this part. So as I loosen this bit again, this bit's so stiff, it needs greasing or oiling or something. I need a tool to help me. So you can see this part I'm moving up and down. That part should be directed straight towards Polaris, and the altitude of Polaris will be equal to our latitude, which is about 51 degrees north where we are. So I'm going to put it on about +51, +51. So let's move that out the way. We're just using the scale here. I'm going 30, 40, 50, that's about 51. And then I've got a little screw thing here, and that allows me to make fine adjustments. All it does is it pushes on the internal arm here. So if I tighten it, it pushes that arm and pushes this scope up a bit more, increasing the altitude. And you do that if you're at higher latitudes. And you can turn it the other way to relax, to move the screw out, bringing this arm down, lower altitudes if we're at lower latitudes. So you can make fine changes to it, which doubtless we'll have to do, but not quite yet. So 51, I've unscrewed it all the way when I stored it. Now I'm going to have to screw it all back in. Oh my God, 4 people are watching this. You losers. 51. Ah, there we are. I can feel that sitting on 51 there. There we are. So that should now be pointed, this part should be pointed at where Polaris is. Polaris is behind those clouds right there, right now. How do I check that it's lined up properly? Well, I need a clear night. And then what I do is, using the scale that's on this bit, I tighten it when this is on 90 degrees. That would be the 90 degrees right ascension, sorry, 90 degrees declination. There we go, 90 degrees declination. And the right ascension is this part. Well, as long as it's all lined up to Polaris. The right ascension of Polaris, syntax error, doesn't make any sense. I mean, I think it's like 1 degree, which would be what, 4 minutes, sorry, but I don't know. That should be pointed right at Polaris, right there, the same patch of sky. So then what I could do is just have a look through that scope, through the viewer scope, and check that it's pointed at Polaris. Yeah, that is true. I am the one putting together a telescope. Right, so obviously I'm going to use the viewing scope to tell whether I'm pointing it towards Polaris or not, and this has actually gone off the camera slightly, so let me move the camera up. Let's get the camera moved up a little bit. Maybe up a tiny bit more. Yeah, that'll do. There we go. So if this viewing scope is pointing at Polaris, does that mean the rest of the scope is pointing at Polaris? Well, not necessarily, because you've got to align the viewing scope. But there's the viewing scope, there. When you look through the eyepiece, you might not see Polaris at all. So you've got to get them lined up. So what I'm going to do is I'm going to use the lowest magnification I've got. Just get my other eyepieces out. Oops, the camera. So I'm going to use the 26mm eyepiece. 26mm eyepiece. I'm going to use that. I'm going to pop that in here. Like that. And I've got to find something very far away. I've got to find something very far away that I can... Yeah, it's pretty cool. There's a lot on it. So I've got to find something very far away. Actually, I probably should have done this before I started doing all this bit. But it doesn't matter. What have I got that I can see from here? I mean, there's a satellite dish over there that I can see. It's not very far away, but it will do. So what I'm going to do is I'm going to use that satellite dish over there. It's only about 200 meters away, to line up the scope with the viewer scope, with a little viewfinder here, so that when I point the viewer, which is easier to look through because it's got a wider field of view, when I point that at Polaris, this will also be pointed at Polaris, and then I can make the fine adjustments to the altitude here, which should be equal to our latitude. So let's go and see if we can find that. So let's loosen that. It's over there. Hopefully the door's not in the way. It's a little bit. Let's come around this way instead. Right. And now you can see the problem. I can't get to the eyepiece. So it's not a waste, but you've got to use it, otherwise it kind of is a waste. So I'm going to have to rotate this scope around because I can't get to the eyepiece. Do you see what I did? I loosened these brackets here and here, rotated it, and now when I'm pointing at that satellite dish, I hope that person doesn't think I'm looking in their window, because I'm really not. Should be able to... it's the other side of the fence. Right, let's get my hat off. Now things just got serious. The other side of the damn fence. Something else I can use. How about that satellite dish up there? No, that's 20 meters away. That's no good. I can see over there. Oh, I can see a tree. Yeah, I could use the top of the tree over there. Now you can't see it, but there's a tree over there. And yeah, if I use the very top of it, I'm not going to use a bird because the bird will fly away, but there's a particularly distinctive set of branches that I could use. So let's get that positioned so it's at the top of the tree. What am I looking at there? Top of the fence. That tree. I want the tree that's far away. Point it right there. So what I'm going to do is tighten everything up when it's there. Then I'll have a look through here, through the eyepiece one, and if the eyepiece shows it's not in the same place, and it won't be, but I'll move it until the eyepiece does show it's in the same place, and then I'll adjust the viewer scope. So I start with the viewer scope because it's going to be roughly the right place, gives me a starting point. Then I'm going to use the eyepiece, then I'm going to go back to the viewer scope. Now I want to rotate this again because I'm not bending all the way down there. There we go. That's going to be more comfortable. We just spray paint this. Some of the bits are scratched on it. Right. So where's my tightening tool? Did I put it in my pocket? No, I put it there. Put that there. Pointing at that particularly interesting part of the branches. Where have they gone? There. Not pointing at a bird because the birds are going to move. Tighten that up. And there's the other one. Down there. Tighten that up. And now what we've got, still moving, what we've got is the ability to make fine adjustments. I'm loosening that, aren't I? Should be that way to tighten it. There we are. So I have the ability to make fine adjustments using these. So these whisker things, we can attach them onto these different parts where these worm screws are, so you can adjust the position, fine adjustment of the position without taking your eye off the scope. So that makes fine adjustments in that direction, and this one, I'll do it the other side so I don't get the two confused. Makes fine adjustments with that one. So that's going to help me line it up, line up the viewer scope. So let's move it that way. That's that pretty distinctive bit there. It's wobbling a lot. Why is it wobbling so much? What have I not tightened? I haven't tightened that. There we are. Well, that bit there is no longer the right altitude, but that doesn't matter. I'm just lining up the scope. Right, there's that distinctive part of the branch. And bring this into focus. Oh, do you know, I'm not far off. Not far off at all. It's not quite the right place, so now I'm going to adjust it so that a particularly distinctive branch is right in the middle of my field of view. Right in the middle. That branch is moving nowhere. Now, if you don't have a branch or anything like that, what you can do is you can use a artificial star. And one of the things I use for an artificial star that is quite good is the torch in my phone and a tripod for my mobile phone, because then it doesn't move. So you just set up the tripod for the mobile phone. Coolest thing I've ever observed. Well, I didn't observe this, but my daughter did. She saw a meteor whilst looking at Jupiter, went across her field of view. I mean, I saw it, but I didn't see it through the scope. She was looking through the scope at the time, and I thought that was really cool. That's the coolest thing I've ever observed. Oh, I didn't. The first time I saw the stripes of Jupiter, that was pretty amazing. The first time I saw the rings of Saturn. That was pretty amazing. So yeah, there we are. That's an artificial star. It's a light, and you can go stick this 200 meters away, and then do the same alignment I'm doing here with the top of the tree. That's quite useful. You can use this for aligning other things as well. Checking your collimation of your scope later and stuff. I don't even know if you can see that that light is turned on. Doesn't matter. So let's turn that off now. Don't hammer my battery. Got more videos to do another time. Oh, a little bit of blue sky. Just a little bit of blue sky up there. We might get lucky tonight. And finally well enough. Right, let's have a look. Yeah, I'm still pointing centre of view. Centre of the view is there. Right, so I'm looking through here, and I'm looking slightly below that particularly distinctive branch. So I need to move it up, and one of the ways of doing that, I can tighten this one and loosen those screws to move the scope up. It takes, again, a little bit of patience and trial and error, and you're trying to do it without moving the rest of the scope. Right, that's better. Now let's move it slightly that way, and now let's just tighten that up a bit so it holds it still. That's pretty good. Oh, it's a bird. Right, that's pretty much lined up now. That's how long it takes. So now that is lined up with that. Let's go back to what I was doing. This was all pointing north. There is the 51 degrees altitude for my to take account of my latitude. Let's loosen these. Pop that on 90 degrees declination. Sorry, 90 degrees right ascension. Keep doing that. Which one is it? No. 90 degrees declination is right. The right ascension shouldn't matter. Let's loosen that. But it shouldn't actually matter. Pop that up there. And that should be pointing directly at Polaris. So now what I do is I have a look through it at the night time and see if I see Polaris. And if Polaris isn't in the middle, I make adjustments, small adjustments to this and to this, not that, to this, the position that the whole of this top table is. I move it round like that, around like that, to bring it back into line with north, and tighten it when I'm looking straight at Polaris. Now it shouldn't matter if I look through that position or that position, they should all be looking directly at Polaris. The light from Polaris is entering parallel, so it shouldn't matter. Did I see the stripes of Jupiter with my scope? Yes. Not with this one, I haven't used this one yet, but with the cheap one, the one that cost about £100, yeah. I saw the stripes of Jupiter and the rings of Saturn, and even the Orion Nebula with that scope. Alright, let's keep going. Because we're not done yet, there's still some stuff to do. So, we got it all aligned. But is the scope collimated? Because this scope has a mirror. It's got a mirror at the top here, a secondary mirror, and a mirror at the back, the primary mirror. And what we need is those mirrors to be lined up so that the light comes straight in, down here, reflects off there, starts to focus, focuses to some point just after this mirror, and then this just allows us to focus on that image that's produced from this lens. So we need to make sure the lenses are, the lens at the back, what do you call it, the mirror at the back, the primary mirror, and the secondary mirror are aligned. And the way we're going to do that is with a special tool called a Chester eyepiece. So we're going to take this one out. We don't need this one anymore, not for now. Let's just pop the lens cap back on it. And this is the Chester eyepiece. I'm going to put the Chester eyepiece on there, and just going to bring this around to there, and I'll be able to actually sort out the alignment with it in the position it is. I don't have to move its position or anything. I can just do it like this, although that's annoying, so let me just tighten that. Put the tighten screw. Big pockets are helpful in astronomy, apparently. There we go. So when I look through the Chester eyepiece, I can see it's not quite aligned. Now I am going to do a separate video all about the alignment, or the collimation as we call it, of these mirrors, because there's no way I can show you what I'm doing really well live. The video I've got planned involves me one camera looking through here while the other camera is watching what adjustments I make at the top and bottom. So it's splicing those two videos together. We use a screwdriver. Let's get out my multi-tool. Another useful thing to have in your astronomy toolkit is a multi-tool. This one has an Allen key, which I'll need later, and it has a screwdriver, which I'll need later. So yeah, I can see right now that it's not lined up. There's an X on the mirror that I drew, and it's not quite lined up. Now I can move the X around with these controls, and I can move the mirror around with these controls. So let's start with the mirror. I've got the locking nuts that are currently already loosened, and then the mirror adjustment nuts. Right. I'll tighten these two, loosen that one, bring it up, bring it up. Have we loosened any more? Should be. Bring it up. So right now I'm making use of just the fact that I've got plenty of light coming in. But if it's night time, and you're collimating this at night time, you need a source of light. And what I use is a red torch, and I can just pop it on the side of this eyepiece, and it illuminates the metal part here, which is what you look at. So a little red torch certainly can help. When you're doing astronomy, you'll have a red torch anyway. 3 people are still watching this. Well done, you're sticking with it. As I say, I'm only doing this so I've got a recording of some footage. Right, let's move this. Reminds me of quite an old Simpsons episode where Principal Skinner has Bart Simpson doing some astronomy work, and it's just reading out 2 numbers and then saying no observation over and over again. That's pretty much lined up with the back mirror, but now the front mirror isn't aligned. So these screws here are what I need, and I could probably actually adjust them with my fingers. It's a bit tight. Let's use a screwdriver on that one. loosen, tighten. Why isn't that one tightening? Let me see if I need to loosen that center one again. Let's get that lined up. To there. Might even rotate the crosshairs on my yeah, might just rotate the crosshairs on my scope as well, so that as I'm rotating this I can see when it's properly lined up with the center. About there. Right. Right, so I do want to tighten this now without moving the mirror on one. Which is easier said than done. Easier said than done. Loosen that one, tighten that, tighten that. Oh, it's making my arm ache. How many have you got? 5 people? Yes. Yes, an adjustment like this absolutely would be needed. They do not arrive collimated. And even if they were collimated in the factory, by the time you get them, they won't be collimated. These Newtonian style ones need to be done every time you use them. You can get some images if they're not collimated, but if you want good quality images, you've got to go through this. But the more you do it, the quicker and easier it gets. This is the first time I've done this one, and it doesn't have the grub screws that you can just use your fingers on, whereas the cheaper scope that I've got that I showed at the start of this does. So the cheaper one I've got is actually far easier to collimate than this one. I keep saying cheaper, I don't know how much this one costs. This one was free, I suppose. It was a donation, so I didn't get much cheaper than that. But I can't quite get the position of the mirror right. So this might take me a few minutes. The other thing is, it depends on the temperature. Temperature changes can affect, oh, gone too far. Temperature changes can affect the alignment of your scope. So you are going to have to do this every time. Right, bring the X in and bring that down. We're getting it now. Right, now that's nearly done. Just loosen this one. And the most frustrating thing about collimating a telescope is I lined this bit up down here, I then lined this bit up, and now that's not lined up. So I need to, bit by bit, you're getting closer and closer and closer to the correct alignment. You can get automatically aligning telescopes. And some people really hate this process, and so would, you know, they ask for telescopes that automatically align. I don't want to do that. I actually quite enjoy lining up the optics. When I was at uni, I spent a long time in a dark room messing around with optics. For some reason, that's not doing anything. Yeah, bring that down, bring that down, bring that down. Nearly there. There. That is now collimated. In so much as it can be. So at this stage I can make teeny tiny adjustments just to get it even better. and I might as well. So let's just bring that down just a tiny bit. Just a tiny bit. You've got to be patient. Be patient when doing astronomy. Now let's move this one just a little bit, but I'm basically circling around the perfect collimation now. There. That's as good as I'm ever going to get. I'm not going to get better than that. So that's now properly collimated. So what have I done so far? I set this up so that this mount was pointing towards north, and I will double check that because I've just caught it and moved it. I definitely need doing. Made sure this was all balanced and level. Made sure that this was all balanced in terms of weight distribution. Set this up so that it was at the right altitude for our latitude. Lined up the viewer scope with the eyepiece so that it's easier to find what I'm looking for in the night sky, and collimated the optics so that any pictures I take through it are going to be that bit better quality. That's what I've done. It's going to switch it for a lower magnification eyepiece again, the 26mm eyepiece, and just see what we can see out there in the trees. Don't kick the legs of your telescope. Actually, that's how I think I broke that one. Right. There's the screw thing. There it is. And that should be on 51. So let's see what we can see. There's a bird up in that tree there. It's in focus. And I can see that bird. And it looks nice. It looks nice and focused. Very top of that tree there's another little bird. Let's just check. Tighten. So I'm just checking that all the optics are lined up, the viewer scope and the eyepiece. I'm still checking, checking all the time. I've got these two whiskers at the end that I can use to make fine adjustments of the position. So I'm moving it up there so I can look at what I think is a bird at the end. Although obviously the optics of this are designed to focus on infinity. It's not quite a bird. Now interestingly, it looks like they are no longer as well lined up as they were. I knock the scope. Yeah, I need to make some more fine adjustments to the viewer scope. I wonder whether, while aligning the optics, collimating it, that knocked the viewer scope out. Oops. Might have done. Yeah. So I'm looking above right now. So I need to bring that down. So loosen that and tighten these two. Loosen, tighten, loosen, tighten. Yeah, looks like I need to do the front ones as well. So loosen, tighten. There we are. There we are, that'll do. So the viewer scope is working fine now, it's all properly lined up, that's all properly lined up. Last minute check. We're down to 3 viewers again. Last minute check. So making sure that the scope is aligned with north. Not quite because I've knocked it. So let's bring that around like that. Like that. Making sure that it is at 51 degrees latitude, which it is. There we are. We're good to go. That's now set up, ready to do some observations. That's how long it takes. So how long was that taking? An hour. It takes an hour. But in that time, all the optics are cooling down, which is what you want. You want everything to be at the same temperature, because otherwise you get turbulent air over the mirror. Which rather messes up your viewing conditions. So that right now should be pointing directly at Polaris. I can check it, blah blah blah. All the optics are collimated and lined up, and this is the right ascension knob. Put it on 0. Off we go. So you can see this one took a lot longer to set up, but when I want to track something, let's say I have found interesting planet. I'm looking at the interesting planet over there, and I want to follow that interesting planet over the course of the night. So I've seen it, I've got it lined up. Oh yes, look at that interesting planet, but I want to keep that planet in view. So all I need to do is use this whisker, which I'm going to stick on the other side, because that's going to make it a little bit easier for me to use. And whilst looking at it, to keep it in view, I just turn it clockwise, and that will follow that interesting planet around. And see what's happening. I'm having to go on my tiptoes, and very soon I'm not going to be able to reach the eyepiece. So I'll have to loosen this bracket, rotate the scope around, but that won't change any of the other alignment. So there's nothing wrong with doing that. From here, I reckon I will be able to see Polaris, which will be fine. I have got to repair this one though, so I'm going to go in and do that now. There, shall I stop the stream? We're done. I said I was going to show you how to set up a scope and talk you through it, and I have. Excellent. More to follow. Maybe, oh, this is an idea. If there are clear skies tonight, I might do a live stream like this tonight. Sit out here and do the observations from here. Don't know what I'll be able to see, but we can try it, can't we? Is a Chester eyepiece required? No, but I can't imagine collimating a telescope without one. Right, let's end stream. I need to get in. And